is Wendy Cheng. I'm a scientific solutions consultant at Benchling. Just a little bit background about myself. I have a background in chemical engineering, and prior to joining Benchling, I have led various automation projects in different process industries, including the food industry. So very excited to be here in such a young and innovative cultured foods industry. And because it's such a young industry, there's constant evolutions going on in cultured foods. And three significant transformations that are happening right now. Number one, there are more novel strains that's being produced with the synthetic biology technology and metabolic engineering out there. There is also an increasing complexity of scale-up data due to the new testing methods that's constantly being introduced. And lastly, there is a greater sophistication of bench scale technology that is due to the high throughput screening methods, the parallel bioprocessing, as well as various automation technologies that is always running at the forefront of technology these days. And due to these significant transformations, we're noticing that the R&D process is undergoing a revolution these days. So this is an overview of the typical R&D process for cultured foods. Of course, there are variations for individual companies on this process, but we notice that typically you start with construct design from plasmid into strain engineering. You have some small scale screening, and then once the strain is confirmed, you grow it up in a fermentation, then going down to downstream purification, and end up with food testing and analytical testing on these samples. So Benchling is designed to work with the entire R&D process workflow. Our platform has various applications built on one uniform data layer, and can go from experimental design with the electronic notebook to in silico sequence tracking, into sample tracking management here, as well as process management, also with a look at analytics with our insights dashboards. We're very proud to work with several leading companies in the industry and have been able to help them grow and scale with them through our partnership as these companies develop their product portfolio. Because of our partnership with all of our customers, we're able to develop some really good understanding of the typical challenges that are seen in this industry. And in today's short demo, we'll be looking at three typical challenges experienced in this R&D workflow. So first, we'll start with what's typically experienced by a strain engineer. What we hear is that they have thousands of plasmids that they're designing, and it's been really hard to keep track of the strains and the parts, the sequences associated with them. So here I'll jump directly into the Benchling platform. So as you can see, I'm still in my browser. Being a cloud-based platform, you can access Benchling anywhere using a browser, logging into your account. Some quick navigation. On the left here is a toolbar of all the applications in Benchling. We have a dashboard showing things that needs your attention and things in progress, as well as an overview calendar of all the projects and experiments that's happening in your lab from the various different teams and team members. So as a strain engineer, I want to take a look at all the strains I have in the system and be able to quickly filter the strains and find what I'm looking for. So if I go into my database of the Benchling registry, this is a database of everything that is in the system. I'll be able to quickly search by just looking at the strains, all the strains that I'm managing in my system, and look at the various properties associated with these strains. So we can associate it to the host strains that's being transfected, the plasmid that's used, as well as look at the gene data that's associated with the plasmid that's used to transfect the strains. So if I'm looking for a particular strain, say I'm looking for all the strains that have contained the legume hemoglobin gene, I can easily search for that particular strain by looking at just the gene field. So in this case, I'm looking for leg H gene. And I can filter that list down to all the strains I've transfected with this particular gene. And if this list is really as long still, you can add more filters. So in this case, I can look for both the leg-H gene and myoglobin gene and really narrow down to a list of all the strains I have and quickly find that strain that has that particular property. And also for these strain, I can quickly manage the sequence that's associated with the strain by directly linking it to the plasmid. And these are all smart links. These blue chips are all smart links. So I can go directly look at the sequence level intelligence for that particular strain directly from that page. So in here, I'll be able to access all the sequence level bases, manipulate the bases, annotations, etc., using the molecular biology tool. So this is a full molecular biology suite. So if you are to do any sequence design work, it can be all linked here with digest ligase. You have primary design, sequence alignment, even CRISPR design, as well as assembly wizard down below here. So now I have my sequence level intelligence here. I can also associate properties to my particular plasmid. In this case, maybe I want to track some configurable fields here. I want to track which project the plasmid is designed for. Maybe it's project beef patty, the creation date of a particular plasmid. And also it's already associated with the gene that it's in this particular plasmid. And because Benchling is sequence aware, we know the biological sequence here directly in the plasmid. I can ask Benchling to automatically tell me what promoters or resistances are in this construct. So it will automatically surface those level of detail to my plasmid to be tracked with my plasmid. So for a strain engineer, these type of data are crucial to in finding each strain and managing the strain. Another great tool to help managing the various amount of strain is through the bulk assembled DNA. When a strain engineer wants to test various combinations of backbone plasmid to inserts, this is a great tool where you can test various assemblies in a combinatorial fashion. So in this case, I have chosen 3 backbone plasmids here and also 3 assemblies. So in this case, I will combinatorially combine each insert to each backbone, creating 9 assemblies in the end. So once this is assembled, I'll be able to assemble all 9 sequences and view them directly in my folder. So these 9 sequences are newly created, and you can see the backbone as well as the insert that's used to create each plasmid. So that was one scenario to help the strain engineer address some of their typical strain management and plasmid creation challenges. Next, we'll take on the role of a fermentation engineer, where a lot of times we hear there's a lot of data that they're managing both online, offline, and they're always stored differently, and understanding the performance of the data is very difficult. So coming back into the platform, as a fermentation engineer, we can templatize the way that each batch is executed through an entry from template directly within Benchling. So this is a way that allows you to enter an execution record for each batch directly. And here I have an entry already started. And you can enter all your structured information directly in a fermentation record here. So in this case, I can create my fermentation batch directly from a seed culture. And because I'm associating the seed culture to my to this run, and I'm associating this is a lineage of the various fermentation batches, it knows which strain, as well as it will surface which plasmid construct is actually used to transfect the strain directly in here. So if I go into my fermentation batch, I'll be able to look at the various properties associated with it, as well as the time point samples that I'm collecting on the batch itself. So if I'm running my fermentation batch, I can collect all the time point samples on this batch, and as well as capture offline sample results on the batch. So this can be captured either manually, so I can type in the OD as well as pH, or upload it through a spreadsheet. So now I've captured my offline data. Benchling can also sync directly with your online data collection to collect all the online data and compare them directly to the offline. So in a dashboard, I'll be able to collect all the data that is collected both online and offline in the same dashboard. So in this case, I can compare product titer, OD growth as offline data, as well as online DO reading or online temperature reading, whatever you have in the system, all in the same dashboard. And if I have all these data collected, I can do some more intelligent trending where we can try to see maybe what produces the highest product titer, what variable produces the highest product titer. We can also take a look at a specific batch. For example, if I'm more curious on my fermentation batch 13, I can filter down all the data to plot just fermentation 13. In this case, I can look at all the online, offline values, but also look at the food sample and food scores that's way downstream that's produced using this particular fermentation batch. So this is the intelligence behind using Benchling and really associating the upstream and downstream batches together. So in this particular plot, if I expand it, I can really trace down the fermentation batches that's used to produce which downstream lot, the product titer of each lot, and the food sample that's created, as well as the taste scores for each food sample based on each particular fermentation run. So this creates a great lineage associating all the batches, lots, and samples that's collected together. And you can also surface any variables that you're tracking in the process. In this case, I'm also tracking media as well as the actual plasmid construct used in the fermentation. So all these blue chips are, you guessed it, the intelligent links of the actual record of the batch. So if I go to my fermentation batch 13 again, I'll be able to surface all the properties of that batch, as well as look at the time point samples collected and the downstream products associated with this particular fermentation. And to finish off the fermentation engineer's role, after he or she creates the fermentation run, you'll be able to transfer the fermentation into particular sample plate right here. So in this sample plate right now, it's currently an empty sample plate. So what I can do right now is quickly insert a temp sample, add all the time point samples here, look for the fermentation samples plate, and be able to look, ask Benchling to find all the available positions in this particular plate. And transfer the volumes associated with it. I'm just going to refresh this. I think something went off here. Just going to let me look at this for a little second here. sorry, that was my internet connection. Now I'm able to find the containers for my fermentation samples plate and transfer this directly to my samples plate. There you go. So if I now go back into my samples plate, I've just created those 12 wells and filled them with 100 microliters in each well. So now I can submit this plate to the analytical team for further testing. Oh, wrong one. There we go. So I can create a request directly from this table here and select the time point sample request for the analytical team and assign it to somebody on that team. In this case, I know it's Charlie. And have entered the project information associated with it. And I like to have a HPLC titer for each one of my samples directly from here. So using this interface, I have just created a request to the analytical team, asking them to perform the product titer test on my samples submitted on this particular fermentation samples plate. And that finishes the role of a fermentation engineer. So we've seen that the fermentation engineer is able to combine both the online, offline data, as well as look at the entire lineage of the downstream batches produced using the fermentation batch, as well as the food samples. And lastly, we'll look at the role of an analytical scientist, where typically they receive a lot of samples from different departments and teams, and managing those requests and turning around the assay results is a constant struggle. So going back into Benchling here, as an analytical scientist, the moment that this request is created, the person assigned, like Charlie, will receive an email saying that the request has been assigned to you and they will be pinned to work on this request. They can access all requests directly through the request portal here. And this request portal is a list of all the requests that's being submitted in the system, no matter the status. So as Charlie, I can come in and search for requests that's specifically assigned to me. And maybe I'm only going to look at the things that's being requested on status. And I can see all the requests that's being submitted for me that's being requested and pending to be processed. So directly from here, I can come in and execute my samples. So in this particular entry, I'm going to be executing a product titer analysis on the fermentation plate that's being submitted. And because I'm doing it in bulk, I'm going to ask Benchling to generate an instruction file that would tell my HPLC what conditions to run, what the samples are. And after the HPLC machine has run, it will generate a results file, and it will and I'll ask Benchling to automatically sync that results file back into the samples and tie it directly to the samples in the plate itself. So this is the lab automation at Benchling, and it doesn't only work with HPLC. You will work with any analytical device as well as robotic handlers. Here, generating the instruction file and putting some context on the samples and associating the results back into the sample records in Benchling. So in this case, I'm going to create a HPLC run here and specify the plate that's being submitted for analysis. I'm going to specify the solvent here with a flow rate and create the run. In this case, I'll ask Benchling to generate the instruction file, and it will generate the instruction file right here. And the syncing will happen also on the back end, and directly we'll be able to have Benchling sync up all the results automatically once that's posted by the HPLC machine right back into Benchling. So it has already posted the run results. It has finished the run, posted the results, and Benchling has processed the results such that it associates itself to the fermentation plate, as well as the samples within the fermentation plate. So the product titer, it comes from the results from the machine, and now it's tied to the plate and as well as the sample. So no matter the results, whether it's online, offline, or captured through lab automation, now if I go into my time point sample results here, I'll be able to see an aggregation of all the results that's captured against that sample. So if I go into results, I'll be able to see the HPLC product titer, as well as the offline data that's collected, and also the person who ran the particular result and the notebook entry or the experiment that it's associated with. So that's the end of my automation run and collecting results from HPLC. Now I can send this entry for review and complete the request ticket. I can also take a look at the overall health of my request portal and look at like how many requests are being processed per week, what type of requests there are, also the request status, who it's assigned to, and be able to look at different samples submitted by different projects and where each project is at on the operational overview. So these views really help manage the various requests that comes in to the analytical team. All right, so through that short demo, we have looked at 3 different scenarios, typical challenges in this overview of R&D workflow. As a strain engineer, we're able to embed sequence level intelligence into strain construction and sample tracking. As a fermentation engineer, we're able to unify both online, offline data, as well as surface the fermentation batches to associate with downstream lots, as well as food tasting batches. In the end, from a food scientist view, we have taken a look at the request portal, how we can effectively hand off requests between one team and the next, as well as use lab automation to really streamline using these analytical instruments in a high throughput fashion. So if you guys have any further questions on anything we can help with software, please don't hesitate to ask right now or send me an email.
Great, thank you. We have a couple questions that are coming in, and so we'll get started right away. We have a question from Brian who asks, Benchling compatibility with lab equipment. What are the interface requirements? What special programming is required to interface to each new instrument?
That's a very loaded question with integration. So we have a lot of instruments that we have been integrated in the past. Benchling offers a very broad suite of APIs. So that's the first thing that we look at is, the APIs exposed about the other instrument as well, like what's the interface they provide on their side. And also through lab automation, we can interface to instruments through either APIs or SQL or other ways as well. So if you have any specific needs, and it really depends on what the instrument is, but a lot of the times when you're looking at a cloud-based software, as long as they have APIs or to talk through database, they can talk to each other.
Great. And as a follow-up to that, we often, at least in the food tech and not just cultured meat, but just food tech in the Bay Area circle, hear about Benchling quite a bit. Would you say, or what would you say is the average setup time for a company that maybe has not been using Benchling at all, but wants to start integrating it? Of course, it varies, but what would you say is the onboarding time?
Yeah, so a lot of the things you saw in today's short demo today is configurable. So the onboarding time, a lot of times depend on how ready you are to tell us to really voice how you want to set up your configuration. Typically, we have seen setup time in the typical range for a smaller setup from 6 to 8 weeks. I think, but for a more complex setup, it could be very lengthy. So it really depends on how complicated your data structure is, and how ready you are to really to figure out how you want to set up your system.
Great. And we have a question that's coming in. Is Benchling GLP compliant?
That's also a very loaded question. So Benchling, we just released our validated cloud release. So that's a complete validated system environment that allows our customers to be GLP compliant. So we offer a lot of features, but I guess the ownership of GLP compliance is still up to the customer on how you use the system. But with our validated cloud platform, we offer an entire suite of validation packages, IQ, OQ, and we can help with PQ services as well. And also every release will have all the validation packages complete as well.
Great. And then follow up from Brian, how is the data in the cloud protected? And maybe an additional kind of segment to that is there an option to do things on-site or on-prem?
Right. So Benchling is a cloud-based platform, and so we're hosted by AWS, and we really take security very, very seriously because we work with a lot of customers, whether it's food tech or biopharma, that their IP is all resided within Benchling. So that's top of mind for us, and we invest heavily in a very managed cloud services that utilize the best state-of-art security designs. So it goes into a lot of details. There's disaster recovery, there's replication going on, and everything is secured in various firewalls and protected in various servers. So that's a very loaded question, but definitely we can follow up with more information if security is something you want to address.
Great. And just last question for those who are either in food tech or cultured meat startups that are just beginning their research phase. How soon would it be beneficial for them to start with Benchling?
So that's it's always better to start sooner, even with just the applications that's beneficial to you right now. As you can see, we went through a lot of things in a very short period of time, from notebook, mobile, to the sample management. If you don't have some the process pieces figured out or lab automation, just to have your data kind of in one platform, starting with the notebook or the registry to sample manage, if you have those, or for in silico design using molecular biology, is way easier if you do the digitalization right now and start that process than migrating from paper or Excel or whatever you're using down the road, because you would have all the information in one place.
Great. And would you say a lot of labs are still using paper for their notebook and research when they're doing data collection?
I think paper a lot of times is irreplaceable. I also still use paper in my day-to-day work as well. But as you grow, the digitalization is unavoidable, as we can definitely experience more right now in the COVID times, where people are remote but need to collaborate more. You can't really see each other's lab notebooks. So it's unavoidable, and it's a great way to share and really remember and find data. I think searchability in electronic format is uncomparable to paper. But yeah, I definitely agree that paper it's widely used and it's hard to give up.
Awesome. Well, thank you so much. Actually, one more question came in. Let's try to answer it if we can. What is the significant competitors to Benchling, and what ways is Benchling superior? What questions should I ask in choosing a data system? Also from Brian.
Okay, very sharp question. So Benchling has a very broad suite of applications, and I think that's pretty unique in our competitive space. We do have a lot of competitors for each maybe single application that's more point system. For example, if you are in molecular biology, then you're looking at Snap, Genius, a lot of the other those type of in silico design platforms. And if you're looking at maybe sample management more, there's a lot of other companies that's like IDBS or other companies in that field, or Lab Notebook. There's a few of those in those point solutions as well. So our applications are really broad and really spread and really unique in terms of that it can unify the data across all those layers. So I guess when you are evaluating various platforms, make sure the platform addresses your needs. So if you are looking to centralize your data, to standardize the way the lab executes experiments, and really have access for in different scientists in different fields, from molecular biology design to sample management, make sure to ask them those questions, like what can they really do? Can they spread the whole broad breadth of needs you're looking for?
Awesome. Thank you so much. That's it for time. If you have any other questions, feel free to put them in the questions for speakers Slack channel. Thank you.
Thank you so much.